tungsten filament lamp, initial cost is less. Fluorescent lamp, initial cost is more. Incandescent lamp, fluctuation in supply voltage has less effect on light output as the variations in voltage are absorbed in the choke. Okay, that is nothing but a coil. It's like an inductor coil. Next, fluctuations in supply voltage has comparatively more effect on light output. Incandescent lamp, it radiates the light, the color of which resembles your natural light. Fluorescent lamp does not give light close to natural light. Incandescent lamp, it works either on AC or it works either on DC. Fluorescent lamp, change of supply needs additional equipment. Incandescent lamp, lumen output 80 to 40 lumens per watt. It is 8 to or 10 to 18 lumens per watt. Here it is only given 8 to 10, but usually it can go up to 18 lumens per watt also. And incandescent lamp, colors of light can be obtained using colored glasses. Fluorescent lamp, by using fluorescent powder, violet, blue, green, etc. Everyone is aware of disco lights. Okay, different types of disco lights. They are fluorescent lamps with the different fluorescent powders. Okay, next, incandescent lamp, brightness of the lamp is more here. Fluorescent lamp, brightness of the lamp is less. Next, light output, it its reduction, okay, it's high with time. Incandescent lamp, light output reduction is low with the time in fluorescent lamp. Working temperature for incandescent lamp is 2000 degrees centigrade and working temperature for fluorescent lamp is 50 degrees centigrade. And the normal working life for incandescent lamp is 1000 hours and normal working life for fluorescent lamp is 5000 to 7500 working hours. Incandescent lamp, it does not have any stroboscopic effect. Fluorescent lamp obviously has stroboscopic effect. You already are aware of this stroboscopic effect from the previous unit. It is nothing but movement of images, okay, observed to the eye, though the images are not moving. Example is your fan. You observe that okay, it is moving in the opposite direction, though it is moving in clockwise direction. You observe it to be moving in the anti-clockwise direction. This is because your eyes are having a stroboscopic effect because of fluorescence observed from the fluorescent tube. Applications of incandescent lamp, domestic, industrial, street lighting. Fluorescent lamps, they also find similar kind of application, but fluorescent lamp main application is in flood lighting. And talking about luminous efficiency, it increases with increase in the voltage of the lamp. And here luminous efficiency increases with increase in voltage and increase in the length of the tube. So you have different types of tubes. For the reason only fluorescent tubes have got different sizes and shapes of tubes obtained. Okay, seen usually. Next, let us understand basic principles of light control. So now whenever the light strikes the surface of an object, based on the properties of that surface, some portion of the light it is reflected, some portion is transmitted through the medium and some is absorbed in the medium. So the method of light control is used to change the direction of the light through a large angle. There are 4 different types of light control techniques: reflection, refraction, diffusion and absorption. We are going to see these 4 different principles, basic principles of light control now. Starting with the reflection. See, the light falling on the surface, whole of the light it will not be absorbed or whole of the light will not be transmitted through the surface. Okay, but some of the light is reflected back. So this light reflection, it happens at an angle equal to the angle of incidence. For example, your light is incident at an angle of 45 degrees, reflection also happens at an angle of 45 degrees. The ratio of reflected light energy to incident light energy, usually it is known as reflection factor. Okay, reflection, again you have got two different types of reflections here: specular deflection and diffuse reflection. What it is? Specular reflection and a diffuse reflection. Specular reflection, it's also called a mirror reflection. Let's see what is specular reflection or mirror reflection. You're observing here in the diagram a source of light, okay, that is incident on a surface. It may be a glass surface, for example. It is reflected back. You have got a normal perpendicularly drawn to the surface, glass surface. You are observing theta being the angle, okay, between the normal and the source of light. Now the angle of reflection is also same, theta again, that is the incandescent light ray that is being reflected back from the surface. Now when the fall of the light falling on the smooth surface, it will be reflected back at an angle equal to the angle of incidence. Such a reflection is known as specular reflection. Understand? Usual ga angle of reflection, angle of incidence rendu exact same unte you call it specular reflection. If there is 1 or 2 degrees variation, it's not called specular reflection. See, with such reflection, observer will be able to see the light source but not the illuminated surface. Most of the surfaces that are causing specular reflection, they are silvered mirrors, highly polished metal surfaces, etc. So plain mirror or mirror similar surfaces, they all show specular reflections. Understand? Next, what is diffuse reflection? See, when the light ray falling on any surface, it is scattered in all directions irrespective of the angle of the incidence. Okay, it's exactly opposite of mirror reflection. It is known as diffuse reflection. Understand? So you are observing the same thing here. Okay, incident angle is theta, okay, to the normal, but the reflected angle is not exactly theta. It is theta 1, it may be theta 2, it may be 3, 4, 5. Example is a frost glass, plaster, blotting paper, any surface that is not a plane mirror source or mirror similar source. Okay, that or surface, that kind of surface is known as a diffuse surface. The reflection observed on a diffuse surface, the reflector, is known as diffuse reflection. In this reflection, observer will be able to see the illuminated surface but not the light source. Okay, in our room, mana room తీసుకుందాం, for example regular room, your house, you may be now sitting in the hall or your bedroom, switch on the light, you are able to see all the objects. That means that it is a diffuse reflection. It's not a specular or mirror reflection. Mirror reflection అంటే మీ ఇంటిని మొత్తం రూమ్ని మొత్తం మిర్రర్స్తో కవర్ చేసుకోండి, లైట్ ఆన్ చేయండి, మీకు ఏం కనిపించదు, మీ మొహం కూడా మీకు కనిపించదు. అర్థమైందా? దట్ ఈస్ specular reflection. And next concept is refraction. Now whenever the beam of light passes through two different medium, okay, having two different densities, okay, say mu1 and mu2, okay, so the light ray, it will be refracted. It will be, some of the light obviously will be refracted. So this particular reflected, this particular refracted right ray, that is incident light passing through one medium to another medium at certain angle, it is known as refraction. See, the light ray, it will be reflected and రాసింది, అది రిఫ్లెక్టెడ్ కాదు, అది రిఫ్రాక్టెడ్. అది ఓకేనా? I'll upload a corrected PPT later on, so I did not see this. Next, here the figure is showing the refraction of light ray from dense medium to rare medium, where mu1 and mu2, they are refractive indexes of the two medium. Theta is the angle of incident. Okay, the incident light ray, it is incident onto the surface, that is the line here differentiating the two different mediums is the surface. Okay, so it is incident onto that particular surface at an angle theta. Okay, so alpha is the angle of reflection. Okay, or you may say refraction అని కూడా అనొచ్చు. I don't know why he has given reflection, but then fine, it is reflection or refraction. Okay, so it's the angle at which it is refracted. So the angle of right ray with normal, it's comparatively less in dense medium than in rare medium. So this particular process entirely is called refraction. I'm repeating it again. You have got two different medium. If an incident light ray, it is passing through that particular medium, okay, it is incident at a particular angle, okay. So the refractive indexes of the two medium is mu1 and mu2. If it is passing through that, the phenomenon of passing of this incident light wave from one medium of a different refractive index to another medium of another different refractive index, you call it a refracted beam of light. The process or the phenomenon, you call it refraction. Understand? Next, diffusion. When a light ray, okay, falling on a surface is reflected in all possible directions such that a surface appears luminous from all possible direction. Okay, this is diffusion. This can be achieved with the help of or usage of a glass screen introduced between the observer and the light surface. They normally employ diffuse glasses. They are opal glass, frost glass, okay, coated with crystalline substance, etc. So also frosted glass is cheaper than opal glass. The disadvantage of frost glass is that it collects more dust. Frost glass is a rough surface, so we need to have it often cleaned. Process of cleaning is a difficult process. So this is diffusion. Absorption. In some of the cases, whole of the light emitted by the lamp source. Here he has mentioned a tungsten filament. Okay, it may be any source. Okay, it will be excessive. So that is necessary to avoid the amount of unwanted wavelengths without interference. So this can be, achieved by using a special bluish color glass for the filament lamp to absorb unwanted radiation. సో ఇక్కడ ఏం చేస్తున్నాము, అబ్జార్ప్షన్ అంటే ఏంటి, ఇది ఎగ్జాంపుల్ తీసుకుని చెప్పాడు. అబ్జార్ప్షన్ అంటే ఏంటి, whenever a light ray falls onto a surface, when the surface is allowing that light rays to pass through the surface, during the process, if the surface or the medium, it is absorbing some of the wavelength of light, the process is called absorption. The same principle, tungsten filament blue color lamps or tungsten filament blue color bulbs lo use chestam. అర్థమైందా? So this is about absorption principle. So what are the four principles? Reflection, refraction, diffusion and absorption.